In this lesson, I want to cover linear inequalities. I want to talk about how to solve them, how to graph your solution, and how to interpret your solution. Inequalities are not all that different than equalities or equations, which we've already reviewed. The obvious difference for an inequality is the symbol. So for an inequality, you have your less than or your greater than symbol, your less than or equal to, or your greater than or equal to. Many times, solving an inequality requires exactly the same steps as solving an equality or an equation. So let's look at this example. Negative 4 plus 5x equals 11. So I have a linear equation shown by my equal to sign. Add 4 to each side, 5x equals 15, and then divide each side by 5. So x equals 3 is my solution. If I change the equal to sign to one of my inequalities, so let's say negative 4 plus 5x is greater than or equal to 11, so I simply change the sign here. The steps to get to my answer in this case are exactly the same. Add 4 to each side, so 5x is greater than or equal to 15, and then I get x is greater than or equal to 3. So no difference in how I get from my given problem to the answer as far as using my properties of equality. There is, however, one really important difference between solving an equation and solving an inequality. Let's cover that now. Let's look at something simple. Suppose I have negative 4x is greater than or equal to 12. So when you look at this, I'm pretty sure that all of you will look at this and say, let's just divide both sides by negative 4, and that's correct. So you're going to divide the left by negative 4, and when you divide the right by negative 4, you get negative 3. Here is where you have to be really careful. When you multiply or you divide by a negative, and in this case I divided by negative 4, you have to reverse the inequality. So this greater than or equal to sign now needs to become less than or equal to. So what did I just say? When you multiply or divide by a negative, you have to reverse the inequality. It's an easy point to forget and overlook, so make special note to pay really strict attention to when you're multiplying and dividing by your negatives. I want you to think about this for a minute, because I really think this begs the question as to why would you do this. If I write negative 5, let's back up, I don't want negative 5. If I write 5 is greater than 2, everybody would agree that this is a true statement. Now suppose I multiply each of these by negative 1. So my negative 5, when I multiply by negative 1, I get a negative 5. And over here, I get negative 2. If I just make this a greater than sign, which is what I was given, I have a statement that is not true. Negative 5 is not greater than negative 2. In fact, negative 5 is less than negative 2. So with this simple example, you can see that when I multiplied both sides by a negative number, it was necessary to reverse the inequality in order to have a statement that was correct. So again, don't forget, multiply, divide means reverse the inequality. Let's do one problem just for practice. Let's see, suppose I have 3 minus x over 9 is less than 4. first thing you're going to do is you're going to subtract 3 from both sides. That leaves you with negative x over 9 is less than 1. 4 minus 3 is 1. Then you have to isolate the x, and in this case you're going to do that by multiplying both sides by negative 9. So right here, this is an opportunity for you to pay attention. Multiply both sides by negative 9. When I multiply the left by negative 9, I'm left with my x. On my right side, I'm going to end up with a negative 9, and I have to reverse the inequality. So right here, my less than sign became a greater than sign because I multiplied by a negative. Let's talk about how you represent your answer to an inequality on a graph. When you graph the answer to an equation, it's a number line with a single point on it because you had one solution. Here, when you solve this, using this one as the example, you have more than one solution. In fact, you have a whole set of numbers that make this a correct statement. Let's look at this graphically, and then we'll see why we have a set. So we're going to graph this. So here's our number line. Let's see, we need negative 9 on our number line, so let's put 0 over here. And we have negative 2, negative 4, negative 6, negative 8, and negative 10. So you're going to graph a point at negative 9. Now right here we have no equal to sign, so you're going to use an open circle. So we have no equal to sign. So at negative 9 right here, we're going to put an open circle, and we need the numbers that are greater than negative 9, so we're going to shade to the right. Like this. So this is the graph that represents the solution to our problem. So notice all of the numbers that I covered in red. All of those are solutions to my equation. So we have an entire set of numbers as the solution. You could pick any number in red, and if you plugged it into the original, it's going to make a true statement. I'm going to start a new problem, and we're going to test this time, and we're going to practice the graphing. How about this one? 5k is greater than negative 9 plus 8k. To solve this, you have a number of choices, but no matter what you do, you have to move all the variables to one side, all the constants to the other. Be really careful about multiplying and dividing by a negative. So let's move the 8k to the left. We're going to subtract 8k from the right, and we'll subtract 8k from the left. So 5k minus 8k is negative 3k. And we have just negative 9 on the right. And then you're going to divide both sides by negative 3. So here, once again, be really careful. We're going to divide by negative 3. That leaves a k on the left. Negative 9 divided by negative 3 is positive 3. and my greater than sign needs to be reversed, so now I have a less than sign. This is my solution. Graphically, your solution is going to look this way. Here's a number line. Put 3 on your number line. 0, 1, 2, 3. Maybe put a 4 here, -1 here. Notice you have no equal to sign right here. Okay, no equal to sign with your inequality. So your circle is going to be open, and you want to shade the numbers that are less than 3. So in this case, we're talking about the numbers to the left. So what we have here is a set of numbers. This represents a set of numbers that solve the inequality. Let's test this now so that you can understand what I mean by a set. Any number less than 3 will make our original a true statement. So let's pick a number less than 3. Let's pick, how about 1? So plugging into the original, you're going to have 5 times 1 is greater than -9 plus 8 times 1. So 5 is greater than -9 plus 8, which is -1. This is a true statement. So 1 is in fact a solution. Well, the red covers a whole bunch of numbers, so we could pick another one. What if we picked 0? 5 times 0, is this greater than -9 plus 8 times 0? Is it true that 0 is greater than -9? Yes, it is. So 0 is a solution to this problem. What you have here is an entire set. We could sit here and pick any number of numbers less than 3, and all of them would work. 3 itself does not work in this problem. That's why we have an open circle there. Let's see, I have some space up here. If I actually plug 3 in, I'm going to have 5 times 3 is greater than -9 plus 8 times 3. So is it true that 15 is greater than -9 plus 24? So is 15 greater than 15? And the answer is no. 15 actually equals 15. So 3 is not a solution, and this is why we have an open circle here. All right, so let's recap. To solve, for the most part, you're going to move the terms around the same way you did when you had an equal to sign. The division property of equality, the multiplication, subtraction, and addition properties of equality. You want to be really careful when you multiply or divide by a negative, reverse your inequality. When you graph your solution, you're going to shade an entire set of numbers on your number line, and you're going to use open and closed circles depending on whether or not you have an equal to sign or not with your inequality. And your solution, unlike an equation where you got one number, this time you have a whole series of numbers. Before we finish the lesson, let's talk about graphing a compound inequality. And a compound inequality has two inequality symbols. So something like this maybe. -4 is less than x, which is less than 2. This is a compound inequality. You can see right here I have two inequality symbols. How do we graph something like this? Well, using this one as an example, this is really two statements. This really means that negative 4 is less than x, and, you notice my choice of the word and, x is less than 2. Let's take a look at our number line here. You're going to need negative 4 and 2 on your number line. So here's 0. As far as points go, you need open circles. Neither one of these has an equal to sign. So you're going to put an open circle at 2, and you'll put an open circle at negative 4. And then you're going to shade. This one over here, negative 4 is less than x. This can be rewritten, if it makes more sense to you, as x is greater than negative 4. These are the same thing. I just stated it differently by using a greater than sign. When you see the word and, your graph is going to be caught in the middle because we have two constraints on x. We have that x has to be bigger than negative 4, but it can go no further than 2. So it is going to be caught in the middle. This is called a conjunction. And again, its special word is and. Take a look at this one. X is less than negative 3, or x is greater than 1. This is also a compound inequality. Notice this time I used the word or. When we graph this, let's set this up first. I'm going to put an equal to sign here. So we have an example of a closed circle. So go back and add that. So first of all, you need your closed circle at 1. And you're going to need an open circle at negative 3. No equal to sign there. All right, now I have the word or. So unlike the conjunction, which looked like this, and the graph was caught between the 2 points, wrong direction, my graph is going to go in the opposite direction this time. So x is greater than or equal to 1, causes me to shade over here, and the values that are less than 3 are to the left. So my compound inequality with the word or, I have a piece of the graph that goes off in either direction. This is called a disjunction. And its special word is or. When you come to class, we're going to do some practice with the simple inequalities. Those are the ones at the beginning of this presentation with a single inequality sign. And you're going to get to practice solving some compound inequalities. Now, I showed you how to graph a compound inequality, so you're going to apply what you learned with the simple inequality, the rules for doing that, to the compound inequality, and you have just reviewed how to graph it. So we will get a lot of practice when I see you in class tomorrow.